So thank you very much for being here today. It is a great pleasure to welcome you to this event, co-managing water in the river and below one's feet to enhance resilience and sustain water services dedicated to conjunctive water resources management approach. This event is organized by UNESCO-IHP in partnership with the Global Environmental Facility International Waters Learning Exchange and Resource Network. In short, this is the GEF IW Learn, and also with the support of the UNESCO Category 2 Center dedicated on groundwater, the International Groundwater Resources Assessment Center, IGRAC. So I will just mention some housekeeping rules, reminding that first that the session will be recorded, and of course you have the usual feature to interact by asking questions to the tool of question and answers, and you will have the opportunity at several times to interact during this webinar. So, well, we will have a quite extensive program today with 2 sessions. And I wish already to thank all the great experts that will intervene today. We will introduce them later when each of them will intervene. Well, and I will not lose more time now, and I wish to introduce our first speaker for the introduction of this first session, who is Mrs. Alice O'Reilly from the groundwater system section, chief of the groundwater systems and settlement section in the UNESCO Intergovernmental Hydrological program. So Alice, floor is yours for the introduction to this session, please.
Thank you very much, Aurelia, and thank you all the attendees and the participants. It's a real pleasure to be today with you and to have the privilege to start the discussion and the presentations and the program of this very important and timing webinar. As you know, I mean, the UNESCO Intergovernmental Hydrological Program is the only real program in the UN agencies that has established since the late 70s a long-term program on groundwater resources. And definitely we are now looking at the long-term approach and the preparation of a new phase, the phase number 9 of the IHP program that will be presented to member states very soon by the end of this year. But let me immediately say that I would like to thank very much IGRAC and the Global Environment Facility, and in particular IW Learn, for the great cooperation that we have established together with the aim of enhancing the knowledge about water resources conjunctive management. One of the results of this cooperation between UNESCO-IHP, IW Learn, GEF, and IGRAC is definitely the publication that will be ready very soon, that will provide, I hope, a valid contribution to the better understanding conjunctive management. I would like to play a particular homage to Jack van der Gaan, who is the Deus ex machina behind this publication that will be published very soon. Having said that, indeed, to achieve sustainable water resource management, conjunctive management in particular, you have to have a very good knowledge of the two water system to be managed conjunctively, so surface water and groundwater. And again, I have to highlight that unfortunately at the global level, our knowledge on groundwater resources and aquifer system is very, very weak. And definitely, as my colleague Neno Kukuric from IGRAC always teach everybody, we cannot manage what we don't know. And the lack of knowledge on aquifer, of course, will impede in several parts of the world to achieve this absolutely crucial new approach on conjunctive management. I would like also to say that the work we are doing on conjunctive management with our partners, and in particular, the work that we are doing with the SADC GMI in the SADC region, in order to improve exactly the knowledge about this new innovative approach. And the work we do with putting together best practices and examples, and I would like then to thank, of course, one of the colleagues, Sebastián Izquierdo Abad, from the Binational Coordination of Ecuador and Peru, that will present a very interesting case today. And definitely what we are doing is a contribution to the achievement of the SDG 6 on water resources. Having said that, I think it's better now to listen to the other presentation, and I will definitely be super interested in listen to the question of all participants to receive information. I want to say that this webinar is registered, is recorded. Some of the UNESCO member states delegation have asked if they will be able to access this program. The program is recorded, and we will inform all the water family members and the delegation in UNESCO about how to reach and to listen to the program again. I thank you so much, and the floor is back to Aurélien. Thank you.
Thank you very much, Alice, for this introduction words. Without waiting any longer, I would like to introduce Mr. Jack van der Groen, who is the lead author, the main author of the upcoming UNESCO publication dedicated to conjunctive water resources management. The publication is almost ready. We have just some final administrative issue to be able to publish it as an official UNESCO publication. So hopefully next month, November, it will be fully available, and so that you can consult it and share it as much as possible. I would like to invite Jack to give us an overview of this conjunctive water management approach and the main content of that is developed in this publication. Please, Jack, the floor is yours.
Thank you very much. Ladies and gentlemen, it is my pleasure to present the content in brief lines, in brief outline of the brochure that has been prepared under the aegis of UNESCO, as mentioned by Alice and Aurélien. I will download the PowerPoint. Yeah. So it's about conjunctive water management. The brochure that is going to appear is a result of the work of a working group, and it covers the following content. So first we start about the physical rationale behind conjunctive water management, and then we come to define it. What is it exactly, conjunctive water management? And then, of course, important to see how to put it into practice. Then we discuss potential benefits of conjunctive water management, and also governance provisions that will facilitate proper application of conjunctive water management. Next, we have a quick look at the current state of conjunctive water management implementation at field level. And finally, I conclude with some ideas about priorities and opportunities for upscaling. So first, the rationale. It's a physical rationale. It has to do with connectivity and transformations in the water domain. First of all, the water cycle. All of you are very familiar to it. Now, what we see in the water cycle is many different components of the water cycle, but they are interacting and they are also transformed one in another. If we look at an element of the water cycle which is anthropogenic, we can call it, for instance, the water use chain. And people, the water use chain is also very illustrative to see the transformations from one type of water into another. Here, for instance, in this example, we start having groundwater. We have an intake, we withdraw groundwater, it becomes a supply of water. The supply is going to be used, this water supply is going to be used for certain purposes. After using it, is converted into wastewater. And the wastewater in turn can be treated, becomes treated water that is discharged, for instance, into open water here, and from there it may return again to become groundwater. And you see this is a kind of cyclic set of transformations, in this case anthropogenically influenced, and let's say the cyclic movement can be in a very natural way, but it can also be in an engineered way to take place. What we see is there is a connectivity of the different forms of fresh water. These different components, atmospheric water, surface water, soil water, groundwater, wastewater, they are intimately connected and they are subject to transformation. So rain becomes soil water or surface water or directly groundwater. The groundwater interacts and becomes surface water, or the reverse, other surface water is infiltrating, becomes groundwater, etc. So we see a lot of transformations. And so the water is not really different. It is just, it gets a name on the basis of the box in which it happens to be. Therefore, because it is so interconnected, it's advisable to manage them conjunctively. And then you would think, oh, this would be common practice for thousands of years already. But in reality, that is not the case. Conjunctive water management is still relatively rare. And we see that fragmented approaches on dealing with water, with surface water, with groundwater, they are still prevailing, these fragmented approaches. We call it sometimes hydroschizophrenia. Now, we come now to defining conjunctive water management. You see here a definition as given in that publication. What is important to see that conjunctive management is based on the idea that the components of the water cycle are considered as one single resource. And therefore, they have to be managed in closest possible coordination, which will maximize overall benefits and minimize potential harmful impacts. conjunctive water management is part of integrated water resource management. It's only one dimension of it, but it is a very important one. Now, this looked very nice, but important is, of course, to see how can we put conjunctive water into practice. And here in the brochure, we made the distinction about two main categories. One is putting conjunctive water management into practice in our planning activities. And secondly, putting the conjunctive water management into practice in the field. So if we look at the first category at the planning level, we see it is based on knowledge of the water systems around, and see how all these connectivities and transformations are taking place. And the main purpose at planning level is to incorporate all water components in conjunction. So for that case, we have to explore and analyze hydraulic connectivities and exchanges of water. If we don't know that, then we cannot do anything properly. Then preventing double counting, because if we are assessing separate parts of the hydrological cycles and we add them, then we see there's a lot of overlap. For instance, 90% of groundwater ends up in surface water, and so if we assess them separately and just add them, then we get an overestimation of the total resources available. And then we identify promising opportunities and also hazards of harmful interaction, because here are the issues that need to be targeted in our efforts for putting conjunctive water management into practice. Now, if we move to the application in the field, then we have three main categories. One is an optimal selection of the sources of supply. So very often we have a selection of the combination of sources of supply, and under this resorts the classical conjunctive use of surface water and groundwater. Then a second category is resources augmentation. Most prominent is what we call nowadays managed aquifer recharge. Previously we called it artificial recharge, but then in the next one, watershed management, desalination of brackish and saline water, that is augmenting our freshwater resources, and recycling treated wastewater, water that otherwise would be useless is being recycled because of being treated and being made usable again. The last subcategory, environmental control, is water level control in polder areas. So it usually makes use of surface water elements, managing surface water levels, and that is affecting also the groundwater levels. Then groundwater level control in surface water irrigated zones. Here we have also combination. We add surface water, we pump groundwater in order to avoid waterlogging. Restricting groundwater pumping to control surface water environmental flows. Here again, wet ecosystems and groundwater are combined. And managing wastewater. This is also an aspect of environmental control that is dealing with different types of water. Most of these things are not visible in the field, but a few of them, yes, they can be easily seen in the field. Here, for instance, we see an example, basin infiltration as one application of managed aquifer recharge. Management aquifer recharge can also be done by dams, recharge dams. Here we see a very large dams. It's a dam of 5 kilometers long. It's in Oman. The same principle can also be applied to very small systems. Here we have a very small recharge dam in Kenya. And here the interaction of groundwater with wet ecosystem we see here in a schematic picture. Here to the right we have an aquifer system which is elevated above the level of the ground level to the left, and we see here this gives rise to permanent springs, and the springs are benefiting forests. So a spring forest can develop below it. Intermittent or permanent streams can be the result of the springs, and that goes to a river. Now, if we are not careful enough, if we just do not control groundwater pumping, the result will be that the springs will dry up and all these systems will degenerate. So we see here protecting a groundwater-dependent ecosystem requires careful control of groundwater abstraction. Now, what are the benefits of conjunctive water management? A number of important ones are shown here. In the first place, it results in more water being available for use, and also lower risks of water shortages. Very clearly, for instance, if you do conjunctive use of surface water and groundwater, surface water is more unpredictable from year to year than groundwater, and so by having groundwater standby to be applied when surface water resources dry up, it's clearly is reducing the risk of water shortages. Water sustainability, I will also illustrate this later. We have environmental benefits, flood control, reduced pollution hazards and pollution impacts, salinity control, ecosystem conservation. Clearly also economic and social benefits, elimination or reduction of planning flaws and errors. That's especially the conjunctive management at the planning side. So by understanding how these different components of the water cycle interact, we can avoid making errors in our planning and eliminating possible duplications. And last but not least, there is a synergy with high-level global policies related to water, like integrated water resources management, climate change adaptation, and especially also the sustainable development goals. So I will show a few of these. Here, conjunctive water use. This picture illustrates the principle of how in a certain hypothetical case, here we have a case of irrigation. Apparently there are two main cropping seasons here in the year. Here we have a river water availability, the mean river water availability, which of course is from year to year different, but this is just an idealized average. And then we see if we use only the surface water, we get curve one here, this between the yellowish and the light green domains. That's the water that is available then for irrigation. And if we combine surface water with groundwater, we see we can move to curve number 2. But what is interesting to see, the difference between curve 1 and curve 2 is not only the quantity of groundwater contributed, which is dark green here, but also it makes possible that more surface water is also being available and not gets lost for irrigation. So here we see the synergetic aspect of combining these two sources. This graph does not show, of course, the economic and social benefits, but these are also present. But this is only to show this more hydrological aspect. Another example of it has to do with sustainability. We could have, for instance, here a situation to the left, a groundwater use equal to this amount, which is consisting of, let's say, sustainable component, groundwater, what we used to call safe yield or something like that, sustainable yield, and part of the groundwater abstraction due to overexploitation of the aquifer. Of course, this is not sustainable, and so by managing, we should try to get a sustainable situation. And now here, Now here, we can think of a number of different interventions. One is, of course, is groundwater demand management, which allows to abstract less groundwater, but we can also use alternative supplies and implement managed aquifer recharge to replenish the aquifer. So we have here two forms of conjunctive water management, and that can result, if it is done properly, in a final situation where we have a sustainable situation and groundwater use without excessive adverse impacts. Another example of the benefits of MAR in this case is salinity control. Here we see a situation of a coastal dune area with a freshwater lens floating on saline or brackish water. In this case, by infiltrating water in infiltration basins. It can also be done by infiltration wells or something like that. We can augment the volume of fresh water here and push down the boundary between fresh and saline water. So we get, in this case, salinity control, which allows to pump more fresh water without interference of saline water. Sustainable development goals, as you all know, these 17 sustainable development goals, many of them are affected by water resources and the availability of water, the quality of water, management of water. And so by improving water management, by conjunctive water management, we also indirectly support the sustainability, the achievement of the Sustainable Development Goals. Now, of course, conjunctive water management requires a number of provisions to be made, governance provisions, in order to make it possible. First one, of course, is, again, data, information, and knowledge. Like Alicia said, citing Neno, you cannot manage what you don't know. Then second one is awareness raising and promotion of conjunctive water management. Most people are not aware of this conjunctive water management and its potential benefits. So you have to make this very widely known and to promote it, to show how to implement it, etc. And part of this is adequate institutions in charge of water resource development and management. In many cases, surface water and groundwater are dealt with in different institutions, which makes it very difficult to combine them properly. So the institutions should be tuned to conjunctive water management, and also should, if they remain in separate institutions, they should cooperate and know of each other's plans and activities. Similarly, appropriate legal and regulatory frameworks. In many cases, the ownership or the user rights of groundwater and of surface water are under different laws, and very often these laws are not consistent. Then the regulations, depending on these laws, are also not consistent. And so in order to implement conjunctive water management properly, there is a lot of work to do to make these legal and regulatory frameworks consistent with each other. Water resource protection policies also needed, otherwise it doesn't really work properly. Water resource development and management planning. So if we do it just ad hoc without any planning, then the results will not be optimal. So in a planning context, the conjunctive water management will give optimal results. And finally, promoting a good gender balance in water affairs. This is a very neglected part of water resources management, but we can do much better, of course, by making good use of all people and making sure that the women are getting a full participation in all parts of the of water affairs. Now, if we now want to make a short look at the current state of conjunctive water management at field level, then we look at these three different categories we have distinguished under field application. The first one is conjunctive use of groundwater and surface water. And we see in irrigation, this is widely applied, mostly in a very spontaneous mode without any planning, but less in a planned mode. So by doing more planning, we can improve the application of conjunctive water management and get more benefit. There is still much scope for expanding planned conjunctive use. If we look at managed aquifer recharge, MAR, and other forms of water resources augmentation, we see that MAR is on the rise since the 1960s. We can see last year publication by Peter Dillon and colleagues have been made, giving a very good overview of what has happened since the 1960s on this very important item. Watershed management is important in several regions, which also contributes to more water being available when it is needed. But also unconventional water sources are becoming more and more important. This includes, for instance, desalinization of brackish water using this, or recycling used waters. Then we move into the direction of circular economies. These are all gaining attractiveness. People is also speaking already, thinking about offshore freshwater resources, which is still a long way to go, but it is one of the possibilities for the future. And then measures primarily intended for environmental control. We see that water level control is widely applied, for instance, in polder areas, irrigated lands, wetlands, and we see that wastewater management is on the rise, but until now, mostly in developed countries. And so in many countries, there's still a long way to go to get wastewater properly managed. Yeah, and then we come to what does the brochure tell on priorities and opportunities for upscaling conjunctive water management? Yeah, you could say all that has been included should be applied, but if we look at what could be priorities, then we make a distinction here into governance measures and field level applications and governance measures. First of all, awareness raising, and second is bridging or removing institutional barriers, because if this is existing, it will be very difficult to apply conjunctive water management. Making legal and regulatory frameworks compatible with conjunctive water management. Next one, aggregating knowledge on the local water systems. This is of course very important, because if you don't know your system, then you cannot see what are the opportunities to apply conjunctive water management. Adopting conjunctive water management in water resources planning, and many of these interventions, they need funding. So we have to think about raising funds for interventions in the field of conjunctive water management, raising funds or thinking about cost recovery methodologies, how to get them, make them financially feasible. And then scaling up at field level. Conjunctive use, we have mentioned already, is very important. Then managed aquifer recharge, watershed management, desalinization, and finally wastewater management and recycling. Then this is more or less what is mentioned and in more detail in the brochure. And so, as mentioned, this brochure or publication is going to appear very soon. And I would like to conclude with showing that it is based on the work of a working group under UNESCO-IHP and also with other contributors. And you see the names of all of them here who have been contributing. Thank you very much.
Thank you very much, Jack, for this presentation, this detailed exploration of this approach of conjunctive water resource management. as you have highlighted, series of concept, priorities, different level and benefits. Well, and as you just reminded, this will be the full detail and more explanation will be accessible within this new publication that will be available certainly next month as official UNESCO publication. I would like to indicate to everybody attending this session, as explained in the chat box, that you can of course use the question and answer tool of Zoom to ask your question to the presenters, and even if you have any experience to share or any experience or willingness to share with some illustration, you can start your question with an exclamation point, and possibly putting in between parentheses your affiliation, so that if we have the opportunity to give you the floor, we will do it. Of course, we cannot guarantee everyone could have the floor, but this is an option, so that you indicate to us that you would potentially contribute. But of course, also just questions are very fine also, and we will consider them through this Q&A tool. So if you have any question to Jack, you can of course write them down during the next presentation, which will be on behalf of it will be Neno Kukurik, the director of IGRAC Center, who will undertake this presentation. There is a small change in the program for a good and happy reason, that Mr. Arno Sterk, who was from IGRAC, who was in the program to undertake this presentation, is not with us today, but Neno is there, of course, to present on this topic of managed aquifer recharge, which is one of the specific application of conjunctive water management, with already many decades of experience, as highlighted by Jack. So Neno, please, the floor is yours.
Thank you, Aurélien, and very good day to everyone. I was just waiting for you to explain why Arno is not here today, and because Arno is someone who is very committed. When he promised something, he does it. But day before yesterday, he became father, so now he's managing something else for the moment, and he asked me to replace him, and I will do that with pleasure. And he prepared presentation. Let me see whether I can share that one with you. And just Aurélien, can you tell me whether you see this?
Perfect, yes, thank you.
Okay, so this is presentation on managing aquifer recharge, which is prepared by Arno. I just modified a couple small things, and IGRAC is, as UNESCO Center, is dealing with managing aquifer recharge for long time, and at the time when Jacques was at IGRAC, and I will remind him on some things we've done at that time. But actually, managing aquifer recharge has a long tradition, and I will try to highlight the main aspects just briefly. The most important here is also that I'm going to present managing aquifer recharge portal, which is probably something relatively new and new for most of you. So I will concentrate more on that one and go quickly through basic principles of managing aquifer recharge. I was smiling just a minute ago because I saw Jacques put this slide at the beginning, and Arno put it also at the beginning. So it is about indeed conjunctive use of surface water and groundwater, because there is no there's no managing aquifer recharge without surface water, and it is conjunctive, especially if you look here at a recharge and from precipitation from lakes and rivers, but also then discharge to the same lakes, rivers, and sea. Anyway, so definition of managing aquifer recharge is actually purposeful recharge of water to aquifer for subsequent recovery. What does it mean? It means that we simply put one or the other way, surface water underground, and we reuse that water in dry periods. It's also known as artificial recharge. This term is still quite in use in the United States, but also as a 3R, recharge, restore, and reuse. And it's very much related to other, well, say, modern concepts like nature-based solutions, green-blue infrastructure, then landscape intervention and planning, etc., etc. The most important is to remember is that it is actually not about allocation of scarce water, but it is catching and retaining extra water and storage, like buffering to bridge over dry periods. So I said briefly about long history of managing aquifer recharge. The lowest, actually the picture, the lowest is one of the canals in Iran. Photo I took quite some time ago. I mean, the history of managing aquifer recharge is 2,000 years old, and you will find excellent examples in Yemen, in Iran, in lots of the other countries in Northern Africa. This is just a brief overview of various managing aquifer recharge methodologies. I will not go in details. You will get this presentation so you can use it later on. But we have basically spreading methods, induced bank infiltration, and all kind of well injections and in-channel modification. And last, which is also part of this, it's runoff harvesting. Peter Dillon tried to put this on one 3D diagram showing, for instance, okay, this is recharge the deep aquifers. This is how we induce filtration to the aquifer from the river, and this is from the ponds, so shallow aquifer, etc., etc. This is these are rooftops, and you can put rainwater harvesting there. This is basically the same, just showing quite, it's a much less details, so you can see more or less various kind of methods. I will go very quickly through those because we don't have much time. Arnaud didn't put rainwater harvesting. Well, I did, and some pictures from all over the world. It's very simple nowadays. You have very sophisticated in large cities with this greening of cities and rooftops and etc. But principle is actually very simple. And then to move to infiltration basins, one of the oldest methods, nice picture from Arizona, simply water coming to these large ponds to underground and then pumping back in dry periods. This is what is called aquifer storage or aquifer storage and recovery. And so basically, infiltrating water, injection groundwater underground in deep aquifer. It has to have a good storage capabilities, and then pumping back. You can pump back to the same well, but it can be also transfer to the other well, and then you can also use that for auto purification, for kind of recovery. This is, I just added this slide 5 minutes ago. This is a sort of aquifer storage recovery, but in coastal areas. And what is interesting here is actually that also extraction of saline groundwater is used in this scheme to increase actually the freshwater lengths. So this is quite interesting approach developed in the Netherlands. Induced bank filtration, very common. You see here actually all the wells, and so water is pumped here and actually coming from river or lake. And famous sand dams, you see that you're actually retaining surface water and then pumping in a dry periods. Very nice example from our friends and colleagues from Acacia. So these are just sum up advantages of storing water underground rather than on surface. And so as you see, a lot of advantages also regarding quality of groundwater and possible auto purification. Well, then I will switch to this MAR global inventory, and that was a first step in the developing of MAR global database. So there were a number of very good partners, and they collected about 1,200 cases as management charge all around the world. There's a nice article written by Stefan Catalan and Nienke Ansens about that. And you see here which are the sources, and these are these cases all over the world. So you can have a close look at that. This is information, they work very systematically, and this is information that they collected, and actually also percentage of information they got. So from all sides, they got a name, but for some other properties, they got just a part of information. But anyway, it was very, very thorough inquiry. So here you see some results of the analysis. For instance, that infiltration ponds and basins are, and aquifer storage recovery, those are the main managing aquifer charge methods used. Here you see that mostly river water is used, and then stormwater. Here you can see, for instance, that in Europe, the induced bank infiltration is mostly used, and in Australia and Oceania is what is that? Well, shaft and borehole recharge, the mostly used method. Here is a snapshot of the cases all over the world from the database, and it's written that the inventory was performed in several languages, which was also quite challenging, I can imagine. And this is a short 2 minutes movie about this database, and I hope that I will manage to run this.
I think we don't have the sound of the video, Menno. So if you want to do the nice voice of the background sound of the video.
There's no sound. Do you hear it now?
But there is a subtitle. We have the subtitles, so we can.
Yeah, but that's a pity because it's nice music. And this is very pleasant voice. But I don't know how to manage this.
Maybe you can add your microphone close to the speakers of the laptop. Just the microphone.
My microphone.
In the headphones. Yeah. The other one.
In any case, it gave an overview, and I think everybody can. In any case, gave an overview, and I think everybody can.
Yeah, well, I mean, this is on it's finishing now, and it's on YouTube, and so basically it is open to everyone. You can use this information, and let me see how to go further now. That's a good one. Yes. So, and also you can add, you can send us information on new sites. That would be great to expand this database. What also is available in the database, and I'm rounding off, it is the suitability maps for some regions. So what are suitability mapping? It's actually regional mapping to show which areas are suitable and for which MAR methods. Of course, MAR is finally locally defined by local conditions, but this can be a good way towards choosing right location. So this is example from the Ameti transboundary aquifer in Kenya, which IGRAC and COASTAR did together. And just to show how detailed this is, because the aquifer has been actually divided into zones, and for each of these zones, the suitability of various methods has been assessed. So it's really a thorough method, and it's quite good for regional analysis. This is just one snapshot from the database where you can see that there are more these suitability maps in the database. Everything's clearly available. And I think I'm rounding off. I was just thinking, put a couple of things about managing aquifer recharge. First function of these methods is indeed storing water for future use, but there are also the other very important functions like the stabilization of or recovering of groundwater levels when we have overexploited aquifers, and also you will see that the reduced losses of evapotranspiration, evaporation lot if you put water underground. Managing saline intrusion, I just show you one example, and land subsidence. And finally, enabling reuse of waste or stormwater. And these changes in climate changes and changes in precipitation pattern and snow melting, we will see more and more need actually for managing aquifer recharge. I couldn't finish without mentioning that there are many organizations dealing with managing aquifer recharge, and UNESCO was one of pioneers with a great overview already quite some time ago. There's 3R Consortium and International Association of Hydrogeologists has excellent actually network which deals with managing aquifer recharge. So that was more or less what I wanted to say at this moment. Thank you.
Thank you very much, Neno, for this presentation. And just jumping on what you said at the end, in fact, we will have also, before the end of the year, a new book, official UNESCO-IHP publication, prepared together with the IH MAR Commission and also the GRIP network on this topic of managed aquifer recharge. So you can watch for the publication of this new book that will present a presentation. Also shows that in fact we could sneak at adding a broad range of techniques that are very at the end and with what is grouped under the terminology of different things as for conjunctive water management, but there is also potentiality to improve better communication about all these aspects.